My name's Steve Thorpe. I'm a principal scientist in the falls prevention team, the Health and Safety Laboratory, which is part of the Health and Safety Executive. I'm going to tell you something about our work on slips, trips and falls and about the test method that we use to measure the friction on floors. HSE are interested in slips, trips and falls because it's the biggest cause of occupational accidents. It's somewhere around 38% of all the major accidents reported to HSE and about a quarter of all the over 3-day, over 7-day accidents reported to HSE. So it's a big cause of concern, it's a big cause of accidents. One of the ways of controlling those accidents is to better understand the surfaces that you've got and understand how they behave in terms of friction. And to do that you need to use a valid test, and the test that HSE uses, HSO uses, is the Pendulum test. The Pendulum test has been around for a number of years. It has been developed and refined over the years, and we have used it very successfully over a number of years. When we see surfaces that give us a good level of friction, we don't see accidents. When we see surfaces that don't give us a good level of friction, then we do see accidents. We also see a number of accidents on stairs. In fact, in the last year or so, we've done a number of fatal stair accident investigations. And you'll have heard a lot about stairs today, and there are many aspects of stairs that are important: dimensions, consistency of dimensions, lighting, colour, handrails. But it's also important if you've got a stair that's likely to be contaminated, so that might be an external stair or a stair in a factory situation, possibly a food factory, to understand the slip resistance of the nosing of the stair, the very edge of the tread that people actually put their feet on. Now, it's not possible to use the Pendulum test on an individual stair tread, but you can use the Pendulum test top and bottom of the flight. You can use it on any landings, and you can use it on the materials before they're fixed to the stairs. And if you understand those materials and how they behave in terms of friction, then that's another control you've got available to help reduce the number of accidents that we're talking about. So the Pendulum test measures the loss of energy, the friction generated when the slider contacts the surface. And we read that loss of energy on the scale here, and there's an important point on the scale which is at 36. At 36, a coefficient of friction of 0.36, we say that people are safe. That's as much as you can expect in terms of the control of the slip risk that you can get from the surface. As the friction reduces down below 36, the risk of an accident happening is increasing. And when we get to the point at about 19 there, that's where about 1 in 2 people are going to be compromised in terms of a slip risk. So those are a couple of important numbers. Let me tell you something else about the Pendulum test. It needs to be set up and levelled. It needs to be a calibrated machine, so these are all the preliminary checks that I will do. And then to make a measurement, I need to introduce the 2 surfaces, the rubber slider, which is a standard rubber that's been developed over a number of years to be typical in terms of the friction that it generates. It's not telling me anything about footwear, it's making a measurement of the floor surface. I need to introduce that rubber to the surface, and I do that by setting something called a footprint. I lower the machine onto the surface we're going to make a measurement on, and then I have to do some adjustments. So I'm now ready to do a test. I'm now ready to measure the friction on this surface. And you see there we get a measurement of about 75 on a clean, dry surface. If I wet that surface, the friction is going to change. I'll spray some water on that surface. My first point would be, can you actually see whether there's water on that surface or not? And in this case, it's probably quite difficult to see that water. So one of the things you can think about in terms of controlling the slip risk on wet or otherwise contaminated surfaces is whether that contaminant, that foreseeable contaminant, is visible or not. But on a surface which gave me about 75 in the dry, simply wetting it changes it massively. We're now down to about 13 on the scale. And if I repeat that measurement, you will see that it's pretty consistent. And if I take a tissue and I get rid of the water on that surface and I do another test, I get the same result. And the reason I get the same result on that last swing was that there was contamination, water in this case, on the slider. So there are two surfaces involved. Keeping the surface clean and dry is important. Thinking about whether the footwear or the foot coming onto the surface is clean and dry is also important. If I do one more little demonstration for you, and this time I'll be a lot more thorough in drying both surfaces. And if I've managed to achieve that, I should be back up to my high dry value. And this time, what I'm going to do is take a wet tissue and basically leave behind the amount of water that most cleaning regimes will leave behind. And you see, with that tiny film of water left behind by a wet mop or a wet towel, an incomplete cleaning process, we've actually got the same level of friction that we had when the tile was completely wet. So keeping smooth surfaces absolutely clean and dry is vital in controlling the risk of people slipping over.